So in terms of safety, there are a lot to do in that. The safety is actually a cell level issue. It's not just the cathode, but also the electrolyte and the anode, which a lot of the new generation batteries use lithium metal. So we've been working on safe electrolytes, for example, aqueous electrolytes and high voltage electrolytes, which are flame retardant. And also we've been working on solid electrolytes, which can protect lithium metal anode. And certainly all of these high energy density batteries needs quite a lot of development in enhancing their safety. And that's a big issue. And generally speaking, nanomaterials have certain well-identified pros for energy. So generally they have fast kinetics because ions and electrons do not need to move very far from the active content. But they also suffer from several well-known problems. One is they usually have low so-called tap density, even though the crystal ideal density, let's say, is 5 grams per cc, but the powder very often is only a tenth of that. So very often you get good energy efficiency per weight, but you don't get good volumetric energy density. So one of our group's research is to enhance the tap density of nanomaterials. So the solid oxygen, we have this cathode material, we have achieved density that's above 2 grams per cc, which is very good. So not only it has a very good gravimetric energy storage capability, but in terms of volumetric energy storage, it's actually much better than lithium sulfur batteries. Even in the at this sort of zero generation lab scales, we are actually already more than 30% higher in volumetric energy density than conventional transition metal-based battery cathodes. And the other problem is they have large surface area, the nanomaterials. So they have something called Coulombic efficiency problem. And in my lab, we've been working on how to enhance the cycling ability of nanomaterials, not only in so-called full cell half cell configurations, but also in lithium-ion constrained full cell configurations. So they can be used in mass production in real battery systems.